So the next that we are going to look at is the winding resistance test. This is another very important electrical test that you carry out on your equipment, your electrical assets. Okay, so this is often a parameter that we overlook as maintenance persons, and this parameter is very important to give us idea as to the health of the electrical asset. Okay, so now the winding resistance test, why is it very important? We know if the windings are a kind of different, the resistance of the windings are a kind of different, that will is capable of inducing voltage imbalance, especially when we are looking at electric motor circuit, can induce voltage imbalance. Then when you are also looking at the generator circuit, that can induce imbalance also on the output of your power system, okay, or your power supply. So now the idea is that if you are looking at the winding resistance, we are looking at, when we are talking about winding resistance, we're talking of electric motors, transformers, and generators. Okay, let us look at the electric motors first. Okay, let's look at the transformers first. So, like we know, the transformers, they are made up of three different winding in each phases. That is on each phase. Okay, so on each of the phase we have the primary and the secondary windings. So each of them, definitely they are wound with the same wires, okay, the same conductor, and then the same number of turns, that is the same length. So which means that expectedly the resistances of each of these phases, okay, whether we are looking at the primary or we are looking at the secondary, on each of the phases they are supposed to be equal. Are we getting it? So if there are differences and the difference is above maybe plus or minus 2 or 3%, okay, that is an indication that something bad is happening within that transformer. It could be shorting within the windings, okay, it could be winding short, and as we well know, that is detrimental to the operations of the transformer. So that is one of the beauty we get when we do the winding resistance test. That's one of the beauty of the test. Okay, give us an idea of the winding resistance, and with that we'll be able to deduce if we have shorted winding that may result to arcing and eventual turning of the transformers. So electric motors too, remember we also have three-phase beds within the stator, and they are wound with the same wire gauge, and we have the same number of turns, okay, on each of these windings, okay, on each of these phase beds. So expectedly the three phases, the resistances, they are supposed to be the same. So deviations is what we are looking at. So above 2 to 2, 3, 5% difference, it calls for some actions. Okay, even if it is newly rewound, the effect is this: once you power the electric motor, remember magnetic field will be created on each of these phases. So the phase with lesser turns, remember as current is flowing through these windings or these conductors in this winding, magnetic field is created around each of these conductors, and cumulatively on the coil, that will now give us the feed winding strength from each of these poles. So if any of them is shorted, it means that the feed strength will be reduced on that phase, and that imbalance, okay, magnetic imbalance, can cause the rotor to be rubbing at that end, because the forces on the rotor will be unbalanced, and it will the tendency of the rotor being pushed towards the end of a lower force, okay, caused by that short is there. So that is one of the danger that we have when we have unbalanced winding resistance. Then the alternator is similar to the electric motors also. We have three-phase belts, wound with the same number, with the same wire gauge and the same number of turns. So expectedly, the three phases, the winding should be about the same. Okay. So let's look at that of the electric motor now. So like we discussed, see the windings of each of the electric motor, they are wound with the same, that is each phase, they are wound with the same wire gauge, and all of them, as you are seeing them here, they have the same number of turns. Okay. So after connection, this is what we have. So the three-phase belt, they are brought to the terminal block of the electric motor. So the resistance of each of these phase is expected to be the same. So this is what you actually have access to, that is the terminal block. Okay, so this is now starred. Are you getting it? So since it is starred, which means that all the windings, all the phase windings, they are connected together. So for us to get the actual resistance reading across each of the phase, we need to remove the shunting bar, whether it is starred or delta'd. Okay, we remove all of the shunting bar. If it is delta'd, that is, they are connected across like this. So you disconnect them. So if this is U1, V1, W1, this will be W2, U2, and V2, which means you expect these two to read together, these two to read together, and this to read together. So your micro ohm meter, okay, which is a low resistance meter, is what you use to do the winding resistance test. Okay, you measure between here and here to get the resistance of the U phase winding. Therefore, the V phase winding is between here and here, and the W phase winding is between here and here. And expectedly, they are supposed to be the same. So if they are different, look at the percentage difference. I mean to say, if it is between 2, 3, and 5, as the case may be, of course, you know that something is happening. Even if it is a new, maybe newly reworked electric motor or generators, and you are having this difference, know that the workmanship was not properly executed. Okay, and that is a ground for you to reject that electric motor, even if it is new. I will get it, because down the line, during operations, it will result to problems in your installation or on the electrical circuit.